Welcome, students. Hope that everyone is fine. Today, we are going to discuss about the topic Newton's laws of motion, the basic principle that govern how object moves. Let's start our class. Rest and motion are common in our daily life. Isn't so? Yes. Then why do objects move? Why do they stop? Do you know how it becomes? Or the answer of this? Newton's laws of motion help us understand these phenomena scientifically. Now we can study each laws of motion and analyze the scientifics of these two questions. Newton analyzed and consolidated the observations made by the Galileo. He put forward new ideas and inferences on the motion of the bodies subjected to force. Later, Sir Isaac Newton, a great physicist and a mathematician, presented the basic three fundamental laws known as the Newton's laws of motion. Now, observe the image of the ball lying still on the ground. Is it moving? Yes, it is not moving. This state is known as rest. When does the ball move? Okay, correct. When we are applying a force only, then the ball moves from its state of rest. Now we can define Newton's first law of motion as every body will continue in its state of rest or uniform motion in a straight line unless and until an unbalanced external force acts on it. This is known as Newton's first law of motion. Now we can analyze some simple examples of Newton's laws of motion. While we are traveling in a bus, the passengers standing in the bus, which is in the motion, tended to fall forward when the bus stops suddenly. Do you know why it's so? When the bus is moving, both the passengers and the bus are in motion. When the bus stops suddenly, the lower part of the body stops first because it touches the floor, but the upper part of the body continues to move forward. This is known as inertia of motion. We can define inertia of the motion as a body in uniform motion cannot change its state of motion by itself. This is known as inertia of motion. Now we can analyze another example. While we are standing in the bus, which is in the rest position, the passengers standing in the bus tend to fall backwards when the bus moves. Why so? When the bus is at rest, both the passengers are rest. When the bus starts suddenly, the lower part of the body moves with the bus. Upper part of the body remains in the state of rest. This tendency is known as inertia of rest. Thus we can say the inertia of rest as tendency to continue in its state of rest is known as inertia of rest. Now we can define inertia as inertia of the body is the tendency of the body to continue in its state of rest or uniform motion. Now we can move on to second law of motion. We can define the second law of motion as the rate of change of momentum of a body is directly proportional to the unbalanced force acting on it. The rate of change of momentum takes place in the direction of the resultant force. Here the rate of change of momentum is directly proportional to unbalanced force. Here, look at a person is pulling a 50 kg and a 500 kg body of masses. For a body, while pulling a 50 kilogram mass, did he pull same force for the pulling the 500 kilogram mass? Yes, different forces are applied for different mass object. We can say that when greater force is applied, greater acceleration is also produced. Now we can derive the equation for the Newton's second law of motion. Now consider a mass of body m moving with a velocity u. When we apply a force F for a time t, then the velocity changes to v. Here the initial velocity be u, final velocity v. We know that momentum is the mass into velocity. Here the initial momentum is m into u, final momentum is mass into final velocity v. Here the change in momentum is m into v minus u. Here the rate of change of momentum is m into v minus u by t. We can write v minus u by t as a acceleration. As per Newton's 4 laws of motion, we can write this F is proportional to mass into acceleration. Here we can changing the proportionality sign by putting the constant k. Where k is a constant, we can put the value of k. We want to find out the value of k. After that we get k is equal to 1, equal to ma. This is the equation for calculating the force. That is the second law of motion. Force is proportional to rate of change of momentum is proportional to unbalanced force act on it. Now look at a simple example. The cricket players move their hand backwards while catching a ball. Do you know why it's so? The ball moves with a large momentum. While the cricket players moving their hand backwards, this increases time to stop that ball, and thus reduces the force or the impact that made on the hands. We can say that by increasing the time, we can reduce the force on the object. Now we can move on to the next law. What does the image is about? Yes, the image is about the launching of the rocket. When the rocket is launching, the gases which are produced by the combustion of fuels move in one direction, but the rocket propel in another direction. Why it is so? Here in the launching of the rocket, here the action is on the forces on the gas, but the reaction here occurs in the forces on the rocket. Here two forces are there. One is action, another is reaction. By this we can define Newton's third law of motion as: for every action there is an equal and opposite reaction. This is Newton's third law of motion. Now we can analyze a simple example. When hammering the nail, what is the action here? Yes, the action here is the hammer exerts a downward force on the nail, pushing the nail into the wood. But what about the reaction? The reaction is the nail pushes back on the hammer with an equal and opposite force. Yes. Does action and reaction occurs on the same body? Yeah. Yes. The action and reaction act on two different bodies simultaneously. As per Newton's third law of motion, we can write an equation for the motion. Here the hammer exerts a force on the nail which is in the downwards. We can write that force as F12. Here the force is exerted by the first body on the second body. But the reaction is on the nail pushes back on the hammer with an opposite force. We can write it as F21. It is the force exerted by the second body on the first body, F21. As per Newton's third law, both forces are equal but are opposite. We are putting a negative sign. Now, did you understand about the three laws of motion? Now we can recall what the laws of motions are about. The first law of motion is known as the law of inertia. A object at a rest stays at rest, and object under motion stays in motion. After we are applying an unbalanced force only, the object changes its motion or the position. The next second law of motion, it is about momentum. The acceleration of the object is directly proportional to net force acting on it and inversely proportional to its mass. Then what about third law of motion is about action and reaction. For every action there is an equal and opposite reaction. Now let me ask some questions. Which law defines the concept of inertia? Yes, the first law of motion discusses about the inertia. State Newton's second law of motion. Yes, correct. The second law of motion states that rate of change of momentum is directly proportional to the unbalanced force acting on it. Give an example that demonstrates action and reaction pairs not acting on the same body. Yes, very good. While we are walking, we are exerting a force on the ground. The ground is also exerting an opposite force on our foot. That is the reaction. Here the action and reaction occurs on the two different bodies. Very good. Let me give an homework question for you or a follow-up activity. Find out more real-life application on Newton's laws of motion. Did you understand the concept, laws of motion? Now we can wind up the class here. Thank you for watching. Explore, observe and relate physics relating to daily life.